today, the 14th of November 2024. This is our business intelligence lecture in Wirtschaftsinformatik number 6. We continue today with our discovery of artificial intelligence, or machine learning, better said, algorithms, and we will look today at so-called cards. So these are classification and regression trees. Is a method to help make decisions, to help a computer make a decision based on data that is not numeric. Not only a computer, you can also use it to make business decisions that are not numeric. It's the most simple algorithm that helps you make decisions. The first concept, we need first to explain one or two concepts. The first concept that we need to explain before we explain the cards is the concept of dirtiness of information. Dirtiness, or in German Verunreinigung. Dirtiness of information. The dirtiness measures the homogeneity, die Homogenität of the data set. Okay. If the data set is homogeneous, the data belong to the same class, and dirtiness is 0. So we measure dirtiness with the so-called Gini index. This is our KPI today. Gini was a mathematician. We write Gini equals 1 minus the sum of 1 to n of p sub I square. Okay. You will see in a minute what this is. P sub I is the probability of belonging to a certain class. Okay, but this is the formula first. You will see in the example that this is not very difficult. So the Gini index is a KPI that measures the dirtiness of data and is always between 0 and 1. Okay. So Gini index equals 0 means that the data is purely homogeneous and all elements belong to the same class. Gini index equals 1 means that the data is maximally dirty and all elements belong to different classes. Okay. So that's the concept of dirtiness of information. Any questions, please? Okay, no questions. Let's see an example, and this is the way to learn. So we have taken data of previous decisions made by soccer associations based on the weather, about the realization of a soccer match. So it rains or not, or it's hot or not, or is sunny or not. We have taken data, and with this data we need this data to start. Okay, so this is the data, as you see. We have 14 values. About the outlook. So the outlook has 3 different possibilities: sunny, overcast, so heute bis wolkig, or rainfall, it's raining. We also have data about 14 days, if it was hot, mild, or cool. We have data about humidity, high or normal. We have data about wind, weak or strong, and then the decision, yes or no, the soccer match was happening or was cancelled. Okay? So these are data that we need and that the algorithm needs to start computing. Without this data, we cannot create our decision tree. Okay? So this is important in case you want to use this method, for instance, to create some decision tree for your bachelor or your master's degree work or Arbeit. You need to go and gather some data that people are deciding whether, for instance, imagine you live in your home with your girlfriend or boyfriend, and you want to decide who does if the man has to clean the kitchen. Okay, so you can ask several questions. Has cleaned last week? Yes, no. Has cleaned? Has had to work? Ask several questions which are not numeric, with different options, and then the decision that was made previously. And with that, you can make a decision tree, which is what we did, which is what we do here. Okay. So the goal is to create a decision tree, and this is also very useful for business. Okay, because in business you need to make decisions about a supplier or about an investment or about whatever, and then you can put several variables there in the columns and then and decide if you make that decision yes or no. Okay, So the first thing we do is we go and so how does this tree look like? So I'm going to give you the solution first. The solution. Okay, so the decision tree is first our is what we want to decide if we do let the match happen or not. And the solution goes like this. It first asks about the outlook. So we take one of the variables, which is the first column, outlook. And then we say, okay, it can be sunny, it can be overcast, and it can be rainfall. If it's sunny, then we ask about humidity. As I said, this is the solution. I will explain in a minute how we get to this. We get the humidity, and then it can be normal, or it can be high. If it's normal, the match takes place. If it's high, the match doesn't take place. If we have overcast, we always play. And if it's the rainfall, we go and look at the wind. If it's a strong wind, then it's a no. We don't play. If it's a weak wind, then it's a yes, and we go and play. So this is the solution that we're going to learn to develop. This is our decision tree. And you can put here other data from a business and say, we invest, yes or no. We buy this machine, yes or no. We build our factory in China, yes or no, and so on and so forth. Based always on previous information, okay? So, does it make sense? So, do you understand what we're trying to do? Say yes or no, please, or go and with thumbs up or thumbs down. It's a very, very useful method if you don't have data. So if you don't have a lot of data, you can go to the street and ask your fellow students if they come with a bike or with a car or with a train or walking based on the weather. And there if you ask, like, let's say 30 students, you have enough data and make such a table as here shown. You have enough data to make your decision tree and make your bachelor degrees final work. Okay, so this is a very useful method to do like little projects, and we can do it with a piece of paper. That's why I explain it here. So let's grab the chart again. I want to grab the chart again here. so that we always have the data close to our eyes. And let's start building the decision tree. So as I said, the first thing we do is we look at our first column, the outlook, okay? So we look at the outlook for our first decision step, for our first branch. So outlook, it's not a numeric variable because it's sunny, overcast, or rainfall, so it's a nominal. Nominal means non-numeric variable. Okay, it can take three values: sunny, overcast. As I said, overcast means high tab is wolkig und rainfall. The three values, okay? So we need a little table. Outlook leads to a yes decision or a no decision and the total, depending on its values. In this little table you need to understand, so please stay with me. If it's sunny, let's look at when it's sunny. 1 time is sunny, 2, 3, 4, and 5 times is sunny. We have 1 no, 2 no's, 3 no's. So if it's sunny, we have 3 times no and 2 yes, 1 yes, 2 yes. Okay? So if it's sunny, we have 3 no's and 2 yes. A total of 5. Could you follow this? I need some confirmation. Yes, no, yes, 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 Diego. All right, so if it's overcast, we have 1 overcast, 2 overcast, 3, 4 overcast. And in this we have yes, 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 and yes. So all yes. So if it's overcast, it's 4, 0, a total of 4. You see, it's not difficult, but you still need to know what to do. Otherwise, it's funny. And then rainfall. We have 3 rainfalls for yes, 1, 2, 3, 4, and 5. 3 are yes, and 2 are no. Okay, so 3 are yes, and 2 are no, a total of 5. So were you able to follow so far? We have a sum of 14, okay? So let's calculate the Gini index for each category. The Gini index for outlook, sunny, is 1 minus the sum of the probability for yes and no squared. So 1 minus 2 divided by 5 square plus 3 divided by 5 square. So this 2 comes from this 2, this 5 comes from this 5, this 3 comes from this 3, this 5 comes from this 5. Okay? This delivers the dirtiness of 0.48 because it's almost 50%. That's 2 yes, 3 no's, so it's not clear. Okay? Does it make sense? This is showing the cleanliness or the dirtiness of the data from the perspective of Outlook Sunny. So if we decide Outlook Sunny, we still cannot know if yes or no because it's almost 50%. So we don't know if we decide Outlook Sunny, we still don't know if yes or no. We need to make another decision. But this is not going to be the case for Overcast. So 1 minus 4 divided by 4 square plus 0 divided by 4 square. This is 0. Okay? So here for Overcast, the information is completely clean. So after Overcast, we can already make a decision, as we will see in the tree. Because Overcast is already clean, we can make a decision after Overcast. It's always yes. Okay? So the Gini index for rainfall is the same as for sunny. Um, 0.48. Okay. So the Gini index for Outlook is the weighted sum so the Gini for Outlook is 5 divided by 14 times 0.48 plus 4 divided by 14 times 0 plus 5 divided by 14 times 0.48. The levers are 0.342 which gives you the dirtiness of the outlook. Okay, so this is made by taking 5 number of total divided by 14 times 0.48 and so on. It's just a weighted sum. This gives you the dirtiness of outlook as a variable is 0.342. This will help us decide which one of the variables we take later. Okay, so let's take the next variable of the chart. I copy again I will be copying this picture many times, so in the exam you don't need to do it, but I do it here for didactic reasons. Okay, remember that number. We take the chart again and we look at temperature. And we do the same. Is a nominal variable, and we have temperature, we have yes, we have no, and we have the total number. So it can be hot, it can be cool, it can be mild, it can be 2, 2, and total of 4, 3, 1, a total of 4, and 4, 2, a total of 6, which gives you a total of 14 again. How do I do this? I just go and say, okay, hot, 1, 2, 3, and 4. And then we have 2 no's and 2 yes. Okay? That's why 2, 2, and then 4. And so on. So the Gini for temperature hot equals 0.5, 1 minus 2 divided by 4 square plus 2 divided by 4 square is 0.5. The Gini index for temperature cool. So this means 0.5 means that we don't know. Okay, it can be yes or no. It's 50%. 1 divided by 3 divided by 4 square plus 1 divided by 4 square. This is 0.375. And the Gini index for temperature mild, 1 minus 4 divided by 6 square plus 2 divided by 6 square equals 0.445. So the Gini index for temperature overall is 4 divided by 14 times 0.5 plus 4 divided by 14 times 0.375 plus 4 divided by 14 plus times 0.445, a weighted value given 0.439. We need to remember this. Okay, so again, we'll look at the next variable, which is humidity. Humidity. Okay. And we look at humidity, and then we say humidity can be high or normal. Then we say yes, no, and the total. So for high, we have 1, 2, 3, 4, 5, 6, and 7. And then we have 1, 2, 3, 4 no's and 3 yes. And for normal, we have for normal, we have 1, 2, 3, 4, 5, 6, and 7 again, and we have yes, 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 6 yes, 1 no. All right. Were you able to follow so far? Thumbs up, thumbs down. Okay, so the Gini index for humidity high. Somebody want to do it with me? Put your microphone on and do it and tell me what to write. Don't want to do it. Okay. 1 minus 3 divided by 7 square plus 4 divided by 7 square. This equals 0.489. The Gini index for humidity normal is 1 minus 6 divided by 7 square plus 1 divided by 7 square equals 0.244. Okay, so the Gini index for humidity equals 7 divided by 14 times 0.489 plus 7 divided by 14 times 0.244, which delivers a value of 0.367. Okay, we need to remember this data later to make the decision, which is our first node. And then we go for the last, which is wind. Oh, sorry. Wind. Okay. Wind is again a nominal value, which is can be strong or weak. Then we have yes, we have no, we have a total. I get the picture again. So here, if we do the same, we have 6, we have 2, we have a total of 8, then 3, 3, and 6. Okay, So the Gini index for wind strong is going to be 1 minus 6 divided by 8 square plus 2 divided by 8 square equals 0.375. 0.375. And the Gini index for wind mild is 1 minus 3 divided by 3, 3 divided by 6 square plus 3 divided by 6 square equals 0.5. You see 0.5, I don't need to do it because it's 50-50, 3 and 3, so it's going to be 0.5. So the Gini index for wind goes and delivers 8 divided by 14 times 0.375 plus 6 divided by 14 times 0.5 equal 0.428. We need to remember this because now we decide based on these Gini indexes. So based, this is important, okay, based on the values of the Gini for all variables, we decide which is our first node in our decision. The variable with the lowest Gini is our first node. Can somebody tell me why? Please, you need to think. So why is the variable with the lowest Gini our first node? No, why is it our first node? Why is it our first node? We cannot take the decision on one node, but why we take, yeah, but why do we take the Gini with the lowest value? So look, we have the future. Exactly, very good. It's the most clean, okay? Yeah. So for Outlook, our Gini was 0.342. For temperature, our Gini was 0.439. For humidity, the Gini was 0.367. And for wind, the Gini was 0.428. So the Outlook is the cleanest variable and delivers, therefore, a sharper decision. Okay? So our first node is Outlook. Our tree looks like this so far. Decision, Okay, this is our decision. The decision can, the first node is Outlook. And then it can be sunny. It can be rainy, rainfall. Or it can be overcast. Let's go up and look at the values we got. For sunny, we got 0.48 Gini. For overcast, we got 0. For rainfall, we got 0.48. Okay, so let's go down, put it there. So here we got a Gini of 0.48. Here a Gini of 0.48. So this means that we still cannot make a decision. Okay. We don't know yet. But for overcast, we got a Gini of 0, which means that we can already make a decision. Because whenever the weather is overcast, it's always a yes. Okay? So this is our decision tree after these calculations. Any questions? Should I repeat any of the steps? Did I go too fast? Please let me know. I am very happy to repeat any part, okay? You just need to tell me. So, okay, no questions. We now go and repeat the same game, but here and then here. Okay? So, let's first go the way of the sunny. Okay? It's more fun. So, now let's now we have Outlook, sunny, and now we want to see which one has more Gini. Temperature, wait, we want to see which one has more Gini. Temperature, humidity, and wind, to see which one is our next node. Okay. So let's look at it. Let's look at Outlook sunny and temperature. Yes, no, and the total. Okay, so Outlook sunny is always sunny. Temperature is hot, cold, or mild. as I said, always sunny. Then if we go and look, we have here 0, here 2, a total of 2. Here we have 1, 0, and 1. And then we have 1, 1, and 2. We have a total of 5. Okay. So the Gini of sunny plus hot is 1 minus 0 divided by 2 square plus 2 divided by 2 square equals 0, which is good because we have a decision already. The Gini of sunny plus cold is again 1 minus 1 divided by 1 plus 0 divided by 1 equals 0. And the Gini for sunny plus mild is 0.5. I don't need to do it because it's 50-50. So the Gini for sunny plus temperature is 2 divided by 5 times 0 plus 1 divided by 5 times 0 plus 2 divided by 5 times 0.5 equals 0.2. Okay, we need to remember this for our decision for the first node. Questions on this? As I said, we are always here now, in this, always on the sunny side, okay? So the same thing we do with sunny. Outlook sunny and humidity. Yes, no, and the total. I copy again our famous table. So outlook sunny, high, and normal. Zero, 3, a total of 3, and then 2, 0, a total of 2. So humidity is going to be good because the Gini index for sunny and high humidity is 0. The Gini index for sunny and normal humidity is 0. The Gini index for sunny and humidity is 0. So I don't need to continue. I don't need to continue. I can make already a decision on this branch. I have found one criteria, which is humidity, that gives me a Gini of 0. So perfectly cutting the data set, I have found a criteria which is humidity, which combined with outlook sunny cuts perfectly the data. The data is perfectly clean with Gini 0, so I don't need to continue. Our decision tree looks like this now. Copy the decision. We have the outlook, which was our first thing. Okay, so our first criteria. And then we had here overcast. The Gini of 0, so I was already able to decide that it was always yes. Then for rainfall, I had a Gini of 0.48, so I still don't know. I need to look at it. But for sunny, I have found something that delivers a Gini of 0, so which is humidity, which has a Gini of 0. And then if it's, we can say that if it's high humidity, we have a decision. It's always a no. And if we have a normal humidity, because we have a Gini of 0, as I said, so perfectly clean, it's always a yes. Okay? Questions, please? What do we have? Yes. Yeah. Because for high is always no, and for normal is always yes. It doesn't the yes or the no doesn't matter. Okay, it's not positive or negative. The Gini is just saying that your information is perfectly cut. So you have at somewhere you have a 0. Okay. Okay. So for high you have always a no, and for normal you decide. So because you always have for sunny and humidity high, you always have no. You can already decide. Okay. And then the decision tree ends there. Yep. So don't get confused with the concept of Gini, yes or no. Yeah, so any more questions? Questions, please. No. Okay, so now we go and say, oh, all right, we are on a good way, but we still have the rainfall. There we have already taken outlook and humidity, so we cannot use them in the rainfall part. We only have the other two, which are so outlook and humidity are gone, so we need to use temperature and wind. Okay. So let's take rainfall. We are here. Okay. Let's take rainfall. And let's see if temperature, which one has a lower Gini, temperature or wind. So let's say outlook rainfall. Temperature, yes, no, and total. So here we say rainfall, temperature can be cool or mild. Here we have a 1, and a 2, and a 2, a 1, and a total of 3. So we have a total of 5. The Gini for rainfall plus temperature cool equals 1 minus 1 divided by 2 square plus 1 divided by 2 square equals 0.5. And the Gini for rainfall plus temperature mild equals 1 minus 2 divided by 3 square plus 1 divided by 3 square equals 0.44. So the Gini total for rainfall plus temperature equals 2 divided by 5 times 0.5 plus 3 divided by 5 times 0.44 equals 0.467. Okay. Which we need to remember to compare it with the wind, which is outlook. Wait, we go to the next page. Outlook. Rainfall, wind, yes, no, total. So if we do that, we have here rainfall, we have here weak or strong, we have here a 3, 0, 3, and here we have a 0, 2, 2. So is this good? And why? Yeah. You can tell me why. If you tell me why, you don't need to do calculations. Yeah. So if you tell me in a sentence, here we see that the Gini is 0 for rainfall weak and rainfall strong because blah 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 blah. Okay. It's a clear cut, so we have Gini for rainfall plus wind weak equals Gini for rainfall plus wind strong equals Gini for rainfall equals 0. But tell me why, okay? If you don't tell me why, I don't know that you understand it. And in the exam, I'm testing that you understand the thing, okay? I don't want to see the that you have it right. I want to see that you understand. So the more you explain me, the better your grade. So because we have found one variable that has a perfect Gini, then we don't need to continue, and our decision tree looks like this. The decision, we have the decision here. Okay. I mean, I can copy it from, so I don't need to write it again. I can copy it from the upper, make a screenshot and use it. This is fun. So I want to crop it. Okay. Okay, I don't know if it's going to be so much fun. Wait. Yeah, I guess that's okay. So I can use this. Our decision tree looks like this now, and then I can say, okay, well, our rainfall, our next variable is wind, okay, because we have Gini of 0. And then for weak wind, we have always a yes. For strong wind with rainfall, again a Gini of 0. We have always a no, and our decision tree ends there. As you can see, we haven't used the variable temperature. Okay, this is a cart classification and regression tree. Soccer. Game. Decision. Okay. So, any questions, please? So I said this is a very useful little method that you can use for your bachelor degree work, because you can take data from your colleagues at the cafeteria, fill a chart on Excel, and make this decision tree, and you have a decision tree for whatever you want. Okay, I'm going to give you one exercise for home, and then I hope you do it. Okay, you don't need to give it to me, but I hope you do it. I recommend you to do it with your boyfriend or girlfriend. So it's about sex. Okay, sex. And sex, yes or no? Okay. Let's say we create some data. I don't know, I'm going just to be spontaneous. We have some data set, and the variables are I don't know, kitchen is clean, kitchen and bath have been clean. Groceries have been bought. Grandparents visit. And stress at work. And then we have a decision, yes or no. So some data, kitchen and bath was clean. We have dirty, very dirty, and clean, very clean. The groceries are big or big Einkauf, big buy or small buy. Small, big, and well, instead of grandparents visit, we stress at work. Wait, stress at work, and time together, talking. Small and big. And then stress at work is strong or weak. Strong, mild, weak, strong. And then time together, long, short, long, long, and then I don't know, yes, no, yes, yes, no. Okay, I don't know, you can expand this as you want. What I need you is to give me your decision tree with your partner. Of course, you can change the data and make your own data as you wish. Make real data with your girlfriend or boyfriend. And just make sure you are going to implement the concept. Okay? So if you want to make your decision tree, feel free. You can gladly ask questions on this exercise. Okay? Questions? Of course, you can expand this in your thinking to some business decisions. Okay, this is, I guess you can do that fairly easily. Anyway, no questions arise, let's stop. Another useful algorithm that we can use for machine learning is called K nearest neighbor, or KNN algorithm. So basically, given an already clustered data set, for instance, with K-means clustering, we are confronted with a new data point and are asked to which cluster the new point belongs to. Okay, so the K nearest network and the K from K-means clustering don't have to do with each other. Okay, so don't confuse both Ks. They don't have to do with each other. So imagine I give you a data set let's say in 2 dimensions, X and Y. With some data, 0, 0, 0, 2, 1, 1, 3, 2, 4, 1, and 4, 3. Okay? This is given. So then we perform, as we already have seen. Okay, I'm not going to repeat it now because we have seen it already. We perform K-means cluster. Okay. And then we see that we have clusters which are A is the point 0, 0, the point 1, 1. I mean, you can do it if you want to. It's just I give you the solution. And the point 0, 2. And cluster B are the rest, the point 3, 2, point 4, 1, and the point 4, 3. Okay. And this is something that we already know, and I am not going to repeat. We know how to do it. We saw it last week or 2 weeks ago, I don't remember. So now a new point comes. New point, new data comes. For instance, the point, let's say 6, 2. Okay. And the question that we ask is to which group does the new point belong to? Okay. And we solve this question. With K-means cluster. With K and N, okay? All right. So in the exam, I could perfectly give you one data set, ask you to perform the clusters, and then in the next question, I could say, okay, given these clusters, if this new data comes, to which group does the new data belong to? So you have to first implement K-means cluster and then KNN. Okay? So this is the roadmap. Let's explain a little bit of the thing. K and N is a supervised machine learning algorithm used for regression and classification. In this case, we use it for classification only. Can also be used to predict. K and N tries to predict the correct class the correct group for the new data. Okay. Then select the k number of points which are closest to the test data. The KNN algorithm calculates the probability of the test data belonging to the classes and assigns the class to the highest probability. Okay. The way to best understand this is to have an example. Okay, is actually the way to deal with it in a. So let's solve the problem from above. We have two groups. We have group A with the data 0, 0, 0, 2, 1, 1, and group B with the data 3, 2, 4, 1, and 4, 3. And we have a new data point set 6, 2. Okay. So we have already clustered, so we know this group A and group B are strong clusters. And let's see where the thing goes. So the first step is calculate the distance from the new point to all the rest of the data. So let's say if we call the new point, let's say alpha, distance between alpha and A1 is the square root of 6 minus 0 square plus 2 minus 0 square. So square root of 36 plus 4, square root of 40. Equal 6.32. Okay, so this is the distance to a point in class A. Good. So the distance from alpha to A2 equal 6 minus 0 square plus 2 minus 2 square equals 6. Again, another distance to a point in class A. Distance to the next point, 6 minus 1 square plus 2 minus 1 square is square root of 26. 5.1. Okay, and then the distance from alpha to B1, it's square root of 6 minus 3 square plus 2 minus 2 square, 0. Square root of 9 is 3, so this is a smaller distance. The distance between alpha and B2, 6 minus 4 square plus 2 minus 1 square, the square root of 5, 2.23. So it looks like the new point is going to belong to class B because the distances are smaller. 6 minus 4 square plus 2 minus 3 square, again 2.23. Okay, so now how do we decide? Take different values of k points in the group and calculate the probability it belongs to one or other group. Okay, so let's see how this is done. For this, we need to make a look. We need to have a look at these distances, okay, and make a ranking. So the first, the closest point is B3 and B1, and B2, sorry, because they have a distance of 2.23. Then comes the point B1, then comes the point A3, then comes the point A2, and then comes the point A1. So this is the hierarchy of distances. So, and now let's look at the probabilities. If, depending on how many points we take, the probability to belonging to one or the other group. So probability is 1 maximum. So if we take only 1 point, so if we only take 1 point B3, then the probability is 100% that the new point belongs to group B, because we only have 1 point. K1 is usually not very useful, so we take K2. Now we take 2 points, and if we take 2 points, also the probability is 100% that it belongs to, because all the points are blue. If we take 3 points, K3, also the probability is 100% that it belongs to the new group, the group B. Okay. If we take 4 points, then it's not 100% anymore. We have 25% probability that it belongs to the group A, and 75% that it belongs to group B. If we take 5 points, we have 5 points, so we have 2/3, 66, no, 2/5, sorry, 0.4, probability that it belongs to the group A, and 60% that it belongs to group B. And if we take all the points, of course we have, if we have a balanced data set, we have 50-50. Okay, so the probability behaves like this. Okay. So for K4, which is the point of minimum energy, or error, the probability of belonging to group B is 75%. Hence, the new point belongs to group B. Okay? So, what have we done graphically? Let's explain the same thing but graphically, okay? We have taken our data set, which is basically the points 0, 0, 0, 2, 1, 1. Okay, so these are the points of the class A. And then we take the points of the class B, 3, 2, 3, 2, 4, 1, and 4, 3. Okay, so these are the points of class B. And then we take another point, which is the new point, which is the point 6, 2, which is here. Okay, alpha. And we ask the question, where does it belong to? To which group does it belong to? So if we see it graphically, it's obvious that it belongs to the group B. So this is group B, and this is group A, right? We have done this with Cummings cluster, we know it, we are safe. But now, what have we done with our Cummings clustering? With our KNN, sorry. Well, we have taken alpha and we have calculated the distance between alpha and all the other points. Remember, this distance was 2.23. So this was the point B3. This was the point B3. This was the point B1, and this was the point B2. Okay. So this distance was 2.23. And then another distance, 2.23, and so on and so forth. Always try to explain math with drawings, okay? This was 3, and the other distances also were calculated to the other points. A1, we measure that for A1 is 6.32. This point was called A1, A2, and A3. So, and the next distance was this one, (6) and 5.1. Sorry. No, we said this was A2. And we said this was A3. So, and then we said this was 6 and 5.1. So this is 5.1. And another distance here is 6. Okay? What we have done is we say, okay, we take 1 point. And if we take 1 point, we take P3. It belongs to the first group. If we take 2 points, so 1 point, we take 2 points, we take 3 points, 4 points, 6 points, until the end. Okay? So we are making circles around alpha, including always more points. In the moment that we find the minimum of this curve, we know that it belongs to the group B. Okay? Does it make sense? Okay, I'm going to take a new point to, now we have alpha. Now with alpha in group, let's say B, a new point arises, beta, which is going to be 3, 0. The points 3 and 0. Okay? So let's calculate the distances. Again, the same thing. So the point 3, 0 is somewhere here. This is beta. Okay, we put it here. So intuitively, maybe you can say it belongs to B. Let's say, no, better than 3, 0, we take 2, 0. I prefer to be more difficult. Beta, okay? So first step, we calculate the distances between all the points. The distance between 2, 0 is 2 minus 0 square plus 0 minus 0 square. This is 2. Distance between beta and A2 equal 2 minus 0 plus 0 minus 2. This is square root of 8. 2.83. Distance between beta and A3 equal 2 minus 1 square plus 0 minus 1 square, square root of 2, 1.414. Distance between beta and B1 equals 2 minus 3 square plus 2 minus 0 square equal 5 square, 2.23. Distance between beta and B2 equal square root of 2 minus 4 square plus 0 minus 1 square. So again, square root of 5, 2.23, and distance between beta and B3 equal 2 minus 4 square plus 0 minus 3 square. So it's 9 plus 4 is 13. Square root of 13 is 3.6. And not forget distance between beta and alpha, because this is a new point that we need to take into consideration. 2 minus 6 square plus 0 minus 2 square. So 16 plus 4, 20 equals 4.47. Okay, we can, of course, make the color coding. You don't need to do the color coding in the exam, but it helps now get information. So the hierarchy of distances is like this. We have A3 with 1.414, then we have A1, then we have B1, then we have B2, then we have A2, then we have B3, and then we have alpha. Okay, so this is the hierarchy. Of distances, and now we paint our curve to find out which K we choose. Okay, so which point is the minimum energy point of our error distribution. So this is P, the probability. So if we take K1, it's always going to be 100% one class, of course. So this is going to be a blue class. A3, okay. If we take K2, it's also going to be 100% a blue class. Because if we take 2 points, the first 2 points are A3 and A1. Then if we take K3, it changes a little bit. It's 1/3, 0.33. 1/3 blue, and 1/3 violet. If we take K4, it gets trickier, 50-50. So we've got already our minimum right there. If we take, so this is 0.50. If we take K5, then it's 0.4. Okay. If we take K6, it's again 50-50. And if we take K7, it gets to the other side. It takes 3 divided by 7, 0.42 on this way. So, sorry. Okay, so this is 0.57. So our minimum is clear. Sorry. The cutting edge is found in K3. K3 delivers best probability. Beta belongs to group A. All right. Questions? So there is no predefined method to find the best, most favorable value of K. There is no way to do it. So we need to test. This is done by a Python code in one line. Okay, so here we do it with our pencil, but this is done by Python super fast. So choosing a small value of K leads to unstable decision boundaries, just like if we take K1 or K2, it's not very good. And taking a too high value of K, so close to the total number of points, also makes no sense. So basically in the middle somewhere is the best. All right. Any questions?